Let's discuss this question. If A equals this matrix 1 1 1 1 1 1 1 1 1, okay, prove that A power n equals this where n belongs to natural. Okay, how do we go about proving this? So one of the approaches with the NCERT people love is the principle of mathematical induction, and we can solve this question using principle of mathematical induction. Okay, is there any other approach? Yeah, there's one more approach, that is you can observe patterns. You can observe, what you can do is you can observe patterns, that is if you have already have A, let's find A square, let's find A power 3, A power 4, and we can observe that this kind of a pattern will be followed, right? Any other approach? Yes, there's one PMI also. Let's use that PMI. Okay. So principle of mathematical induction says that let us assume the statement Pn. What is the statement Pn? Pn is this statement: A power n is equal to this over here, 3 power n minus 1, 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 and there's another row. What is that row? This is 3 power n minus 1, 3 power n minus 1 for n belongs to natural. Now for proving this, the principle of mathematical induction says that we have to apply 3 steps. We have to apply 3 steps. The first step is this particular result should be true for n belongs to natural. So the first step, we'll check P1. What does P1 say? P1 says A power 1 is equal to 3 power 0, 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 which implies A is equal to 1 1 1 1 1 1 1 1 1. Can you observe that? This A power 1 is A and 3 power 0 is 1, right? So A equals to this, and is this statement true? Yes, this is true. Step 1 says P1 is true. So P1 should have been true, yes. Once you have found that P1 is true, the next step that is involved is Pk. Assume Pk is true. Assume that Pk is true. Okay, so what does that imply? Implies that A power k, instead of n, what I'll do is I'll substitute k, right? So A power k is equal to 3 power, instead of n I am substituting k, this is 3 power k minus 1, 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 again 3 power k minus 1, 3 power k minus 1. That's all that we have, right? This A power k is equal to this. Once we have assumed this, now it is time to apply the step 3. What does step 3 say? Step 3 says prove Pk plus 1 is 2. That is, what we want to prove is, instead of n, if I substitute k plus 1, the result, that the statement should be actually true. So what we have over here is A power k plus 1 is equal to 3 power k, 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 3 power k. This is what we have. We are supposed to prove this one. Okay. So for proving this one, what do we need? We need to start with the LHS first. Okay. Let's begin with the LHS. LHS is equal to A power k plus 1. Now what is A power k plus 1 equal to? A power k plus 1 can be written, we have to use this expression over here, right? We have to use this statement since this is assumed to be true. So A power k plus 1 is equal to A power k times A. Now what is A power k? You may observe that A power k is this 3 power k minus 1, 3 power k minus 1, 3 power k minus 1. Okay. So let's use that. This is 3 power k minus 1, 3 power k minus 1, 3 power k minus 1. This is again 3 power k minus 1, 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 same. And what is A? It has to be multiplied with A. This matrix has to be multiplied with A. A is, this is the matrix A. This is the matrix A, as you can clearly observe, right? Now, let's go about multiplying these two, and will require some more space, yeah. So Can we erase this? Yes. This is Pn is this statement. So let me write this is Pn over here. Okay, and P1 is true. Nothing else is important in this. So let's get rid of this one. Once we get rid of this, let us solve that LHS, which gives me LHS is equal to what? LHS is equal to, multiply this first row with the first column. So 3 power k minus 1, 3 power k minus 1, 3 power k minus 1 get added 3 times. So this is 3 times 3 power k minus 1. Okay, and can I write it as 3 times 3 power k minus 1? Can further be written as 3 power k, but we'll write it in the next step, not an issue. These 3 get multiplied with this 1, 1, 1 and we get the exact same thing, right? So this is 3 power k minus 1 into 3, which is 3 power k. The other terms would also be 3 power k, 3 power k, 3 power k, 3 power k. All of these terms would be 3 power k, as you can observe. This is also 3 power k, yeah. So all the terms are 3 power k. And we started with the LHS. What have we obtained over here? This LHS is equal to this, which is actually the RHS of this sign, right? Which is equal to the right hand side of this, and this is what we started, which we wanted to prove. Let's prove. Okay, so by PMI, by principle of mathematical induction, we can say that Pn, that is this statement. By the principle of mathematical induction, this statement that a power n equal to this, by mathematical induction, we can say that this statement is true. By the principle of mathematical induction, we can say that Pn is true, using, since we have followed those 3 steps of principle of mathematical induction over here. That's all? Yeah, that's all in this question.